Yeah, I don't know if you can reset it or something, but I got nothing. I'll have to keep using my phone.
Oh no. That's so weird because I woke up this morning and my internet was out too. I had to go and reset my router. Super weird. Yeah, I didn't lose my power. My router went out. I'm not sure why. I know I paid the bill. All right, let's see. Missing Andrea. Avery. Where's Mona? There's Avery. There's Yennefer. Oh, that's fine. It's just 8:40 now. So, how is everybody today? What is this? Day 4,872? That's what it feels like. Brittany, look the way I feel right now.
When I took your test, I did the homework right before, and I was like, okay, this is great studying. I have it fresh in my mind. I took your test, and I was like, oh my God, I'm a moron. Like, for some reason, like, the wording was totally different. So, like, every question, I was like, I'm going to guess this one. And when this morning, when I looked at the grade, I saw the date was like 3/23, and I was like, oh my God, I only got 3 fucking right. I was so scared, but then I looked at it, and I like did way better than I thought I was, but I was so uncertain. I was like, because there were so many little tiny things that you just seemed like you worded a slightly different, and it threw me for a loop, and I was just like,
oh no.
I'm gonna guess that one kind of thing.
I tried to word it as similar as I did. I tried to get it as close to how we talked about it in the lecture.
There was one of them that was like 4 different things, and only one of them said protein, and I was like, all of these things were in that talk about that thing, like the pores and the selective, like allowing things selectively to go in there, but I was like, still known this as protein, so I think that's the actual name. scores, and I was like, it was just like small, minute things like that that are just like had me second guessing myself ridiculous amount.
Don't do that. Don't second guess yourself.
Yeah, I went back through it a couple times, and I was like, well, I just got to go with what I've got because I'm just gonna keep changing answers or.
Well, I'm sorry.
Oh, it's cool. I just need to hardcore buckle down on that so I can like feel more confident when the midterm comes around.
Right?
Miss Huff, how does Dropbox work? I tried so hard to figure it out last night. I don't understand it.
Same here. I
Should-
think I don't know if it went in there.
Do what, Case?
I don't know if mine went in. I tried to do it and it says it's like sharing it with you, but I wasn't sure if it was the right way to do it.
Oh, same. I had such a hard time with Dropbox last night.
Well, that's my goodness. I thought that would be the least of the things that you'd have trouble with.
Technology, it don't exist.
You guys are the ones who are supposed to be amazing with technology.
Whoever said that lied.
Minute, like it wouldn't give us an option to like open up our files and put it in your file. Like it just said this Dropbox is in. That's all it said.
It
Yeah,
should have given you an option to share.
No, it says you wanted to like be a member. Otherwise,
Mm,
you download your empty file to our computer.
that's weird.
Miss Huff, it's Bernadette. I'm in class if you can't see me.
Hi, Bernadette. I heard you were having trouble. I did get you.
Yeah, we're still trying to reset it. So I'm on my phone right now. So it probably might come up as Samsung Galaxy.
Yeah, no
That's
worries.
my that's
was
my
just
alias
saying.
name.
So weird that right 5 minutes before class, my internet went out too. And
I
I-
woke up this morning, nothing.
Yeah,
We're
I had to
still trying
reset.
it.
So, but when I
Hopefully
reset
should
it,
be good to go.
yeah, it worked fine. All right, so okay, so there's Andrea. Tavanna did not. Ty, did you come in here, Ty? Nope. Jade, yep, there you are. I see you. Cheyenne, I see you. Rob. Where is Sir Rob? No Rob. Turn on my chat. So, no worries about the Dropbox. Let me go in, find out what went wrong. I'll send y'all instructions. Not to panic. Don't worry.
Miss Huff,
Yeah.
Okay, because I've done nothing but panic because I really, really hate missing grades and I could not get it in.
Okay, so let's just do this going forward. Nobody's gonna panic about anything. If you have trouble handing something in, we will work through it together. That's okay. This is a time of learning for all of us. So
can we try turning in through? Can we try turning our homework in through DocScan? That worked with me in Mrs. Rivera's class, but I know that you'd said to do it in the Dropbox. But can I try sending mine after class through DocScan?
I don't know what that is.
So what it is, it's an app on your phone, and you take a picture of your worksheet or whatever you're going to send in, and it converts it into a PDF. And then I can send it directly to your email address.
Okay, so it sends it to my email.
And it'll come in as PDFs. And I just wanted to ask if I can try it that way after class to see if it works.
Yeah, try it that way. I'm gonna have to think about that. I may have to create a new email address for assignments.
Okay.
Just because the only thing is, and that's a possibility. I can certainly get like a new Gmail or an Outlook account just for assignments. Because my concern is I have so many assignments, or not assignments, so many
Emails?
emails, because my work email right now is being forwarded to my personal email. So I have about 170 emails a day. And I worry that adding another 60 emails, you know, something's going to get lost. If I'm just going to be completely honest. Can we try submission through Edmodo? I don't know. Can you? You, like I said, okay, that's what everyone else has been doing, Brittany. Okay, yeah, let's do that. Do I have to see if I need to? I don't think I need to set anything else up.
I think you just have to make the assignment, and then it gives us an option to link the assignment to that.
Okay.
Submission to it.
Perfect. All right, since that's what everyone else has been doing, let me look into that. So what we're gonna not do is what?
Panic.
Panic. We are not going to panic. No, we're not gonna panic.
Panic.
No. Guys, we figure this out together. We're in this together. So if you can't hand in an assignment because the technology is not working for you, I am not going to dock you points for that. That's not your fault. That's not fair. I'm a pretty fair person. Mona, stop. Stop. No, we'll figure out the Edmodo. We'll get you to hand it in as soon as we get the technology going. It's all good. It's all good. It will, as Mr. Hamilton always says, all will be well. All will be well. So we'll get it figured out. No worries. So if you did not hand it in yet, don't worry about it. We'll get it done. We'll get it in sometime before the weekend. You'll get your points. All right. So did Rob say that he came in? I did not see him.
He's coming.
He's coming. All right. All right. Did Ty come in? No. All right. So now that we have got everyone from jumping off the cliff and excuse me. All right, so today we are going to continue on with our lecture over mitosis. So, oops, let me get in here. There we go. All right. Sorry, getting my stuff ready here. Okay, so yesterday, everyone muted. All right. So yesterday we got going through our endocytosis, exocytosis. We talked about our passive versus active movement of things in and out of the cell. Remember, passive is you do not need energy. Some of our passive methods were like diffusion, facilitated diffusion. So diffusion was with the gradient, remember, from high to low. Facilitated was I'm getting a piggyback ride and I'm getting some help. We had osmosis, which is the movement of fluid or water. And finally, we had filtration, where we are using force to push it through. With our active transport, we had endo and exocytosis. Endo to take things into a cell. And the methods by which we were doing that, we had phagocytosis, which was the engulfing of solid materials, and we had pinocytosis, which was the engulfing of liquid materials. You can't see. Can everybody see the PowerPoint except for Casey? Is everyone?
I can see it.
I don't know what to do, Case.
I don't know what happened. I think I'll like log out and then come right back. Maybe
Yeah, go
it'll-
ahead. Go ahead. Do
Oh,
you.
okay.
You do you. All right, I got you, Ty. All right, so pinocytosis is where I'm going to lose my voice today. Holy smokes. Pinocytosis is the engulfing of liquids. I remember that because of like a Pinot Grigio. You know, Pinot Grigio is a liquid. And then our exocytosis is the exact process, just in reverse. So is everybody okay with how we are getting things in and out of the cell? Any questions before we move on? Because mitosis is pretty darned exciting, I have to say.
I'm in. I got my internet working.
Yay! Put this on airplane. All right. All we did was a little bit of review over the way we were moving things back and forth through the cells.
Okay.
All right. So how do cells divide? Cells can be created by a multitude of different ways. We can divide them by having a contribution, wow, that, Doug might have just had a stroke. Contribution of two other cells and do a mishmash. That's going to be similar to what we see in reproduction, where you have a sperm cell, you have an egg cell, they come together, they blah, 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 and you get a unique individual cell as a result. Mitosis is different in that we are going to have an exact copy replica. That's what we want. We want the DNA to be an exact copy replica. And so that's the method we're going to focus on for this particular chapter. So the phase that the cell spends most of his life in is going to be this interphase. Now, what interphase really is kind of the life phase. It's when he's growing, it's maturing. We say differentiating, but really all that is a fancy word of figuring out how to do his job when he grows up. He's trying to figure out, he's reading the DNA manual, he's figuring out what he needs to do. And so it's in this phase, this interphase, this, put a little star beside that, this is one of those that would be an amazing multiple choice question. And in fact, that's the mindset that I want you guys to start getting into, is when you start looking at these slides, ask yourself, as a teacher, if I was teaching this class, is this something that I think would be a good question? And my answer to that on this slide is yes. Yes, it is. This is a great question. In which mitotic cycle does the cell spend the majority of its life in? Interphase. All right. So the cell is not actively dividing when we are in interphase. It is growing, it is preparing. Now, originally, I think we talked about this yesterday. Originally, we used to call this phase the resting phase. And then we realized that's not really the right thing the right term to use to describe it. The resting phase makes it seem like the cell's not doing anything while it's in this phase. And that's not true. It is carrying out its normal job. It's doing its daily thing. Boop, boop, boop. It's just not replicating. And so we've changed the name scientifically now from the resting phase to what we call the metabolic phase. And metabolic simply means that you're going about your daily life. Metabolic means we're just keep on keeping on kind of thing. Now, during this metabolic phase, this inner phase, this is where we do see a very visible nucleus, which is where all of our genetic material is going to be found. So how do we replicate it? Well, we get one strand of DNA, we unzip it, and we end up with 2 strands of DNA. This was a lot of words. So did I show you guys that video yesterday? Was it you guys or the other group?
We watched it.
We did.
You guys did the Amoeba Sisters. I love the way they break it down and explain it. And if you notice, a lot of the terms that they use are right up here. On this slide, there's one primary thing that I want to make sure everyone is okay with. Yes, knowing the term helicase and polymerase, go back, rewatch the Amoeba Sister video. But my big thing is right here. The lead strand and the lag strand. So we're just going to review real quick. And I want to make sure that everyone understands the difference. So when I have my DNA, so here's my DNA. You all get to benefit from my beautiful drawing skills. All right, so the first thing we learned in the video was I got to break it apart because we've got all of these nucleotides, right? Apple tree, car in the garage. And I need to break the bonds in between them and unwrap this genetic material. When I unwrap it, I end up with these 2 straight strands that were once connected together. And when they connect, that's when they do this little windy thing. Now, the way that I reassemble, oh my gosh, I'm going to lose my voice. Excuse me, I'm so sorry. All right, so the way that I need to reassemble, so these are all of my nucleotides. This is adenine, guanine, cytosine, etc. Here I've got on the opposite side. So from this half, so this is half and this is half. From this half, I can, what happened? I can reassemble this entire DNA because we know which nucleotide bonds with which nucleotide. So this strand here is called the leading strand because the way that it gets reassembled is in this direction. So what that means is I can assemble continuously in this direction. The lagging strand has to be reassembled in the opposite direction. And so what that means is we reassemble, and we now have to reassemble, and then reassemble. And so we have this lag. I mean, right now we're all having laggy computers and laggy internet. That's why this one's called the lagging strand, because it has kind of this stuttery lag action as it's creating itself. Comments, questions, concerns about any of that? What questions can I answer for you?
Is there a cartoon little thingy of the stars regarding this part?
The Amoeba Sister video that we saw yesterday outlined all of this about the leading strand
Oh, cool.
and the lagging
I promise I'll
strand.
listen.
Yeah, go back and review that video that we saw yesterday. I showed that one during class.
Yep.
So, and that one went through. Now, they went a little bit more in depth. They went into the 3 to 5, 5 to 3, and basically went over the structure. Yeah, we didn't go that deep. My big thing is that, you know, we're going to unzip the 2, reassemble them into 2 identical DNA, but the way that they're going to be unzipped and reassembled is slightly different.
Okay.
So
Thank you.
I have a couple of pictures here. All right, I will. Here we go. Stop. Okay. So this is what I'm talking about. So here I have, move you guys over here. Here I have the DNA. Did I freeze? Am I frozen? I am frozen?
Sure is. I can hear you.
Oh dear. Let me. All right. Can you hear me now?
I can hear you. I just sometimes your picture freezes.
Oh,
Can you hear us?
I can hear you. How about everyone else? Can everyone else hear me okay?
Yes. I just it's frozen.
I'm
Yeah,
good here. It's just when everyone else talks, it sounds bad. It's like it's the connection's bad for everyone else, but you for some reason.
Yeah, I don't know. Apparently the internet is super, super duper slow today. We broke the internet, Casey. We broke the internet. Because you guys keep freezing on me too. Crazy. All right, well, we'll just continue and keep going. It's frozen again. You know what? I think some of you are messing with me that every now and then you're just like, and you're not actually frozen. You're just pretending that you are. That's my own theory. How do you know I'm not pretending? Maybe I am. I'm not. All right. Well, we'll muddle through. Let's just keep going. Let me get this up. Okay. So what I'm referring to when I am talking about this leading and lagging strand. It keeps coming up saying my internet connection is unstable. All right. So
Getting unstable.
yeah, I keep getting the message that my internet is unstable right now. So we'll just keep going, just do what we can do. Here is where we are unwinding and unzipping. So here we have unzipped our 2 strands, coming up with each a half, and then we can match our nucleotides and come up with 2 exact replicated strands. Now my chat won't come up. Oh my goodness gracious. Today is going to be the day. Oh, Ariel's having issues getting back in. Okay. Today is just, I don't even know what day it is. Is it today? What day is it today? Is it Thursday?
I think it's Thursday.
Thursday. I just had to check too.
Okay, it's Thursday. Yeah, that's probably a good thing for me to remember. Okay. All right. So here we go. I know. Am I still freezing on you guys? Apparently, yes. Huh. So, I mean, there's not a whole lot I can do. I have full bars on my internet.
I'm just gonna say, like, you're not freezing at all for me. Everything's been coming up pretty clear.
Okay, good.
I'm with Jade. I can hear you fine. It's just sometimes on the little view, your little monitor, it looks like you stay frozen for a while, but your voice
Yeah,
continues to
that's
go.
about it.
Oh, okay, so you can still hear me okay.
Yeah,
I can't hear you and you don't move.
Someone can't hear me?
Sometimes I can hear you and sometimes I can't hear you and you don't move at all.
Oh, so I just need to make sure that I continuously move the whole time.
Yes, please.
Okay, sure, no problem. Okay, so I don't know if I can lecture like this. Okay, oh, you guys are just so funny. Oops, nope. All right, so there we go. So basically what we've got going on is we have this strand of DNA that is breaking apart. And here is what I'm talking about with this leading and lagging strand. So as you can see, as we're unzipping, this is the strand that just reassembles. As it's unzipping, it's reassembling itself. So it's a continuous reassembly. This lagging strand, however, can only assemble in this direction. So it will reassemble, but then it's got to go back and reassemble, and then it's got to go back. And so this is the one that's a little bit stuttery. And that would be why, just like our internet right now, super laggy, that's the same thing happening here. So that's the big concept that I need you guys to take from this, is the difference between the leading and the lagging strand in the creation of these two identical copies of DNA. All right, so when we are looking at this cell reproducing, as you can see, as we said, the cell spends the majority of its life in this interphase. We also call that the metabolic phase. This is where the cell is just doing his life, doing cell stuff, doing what he needs to do. And then we have the active dividing, the dividing stage. This dividing stage is separated into three subcategories. We have G1, which stands for growth. And basically what's happening in this growth, so if I have one cell that is going to become two cells, I need that one cell to get much bigger, because the two cells, once it divides, are going to be the same size as the original cell. So during our G1, or our growth phase, the cell is going to double in size. During the synthetic, or S phase, this is where we copy our DNA, and we now have a perfect replication, one for each cell. Here during our G2 phase, this is where we are actively getting ready to split into two cells. So all of this is preparatory. We have expanded, and our cell is now doubled in size. We have replicated our DNA, and now in G2, we're making sure that the cell has the proteins and the enzymes and the nutrition that it needs to divide. We've not divided yet. This is all preparatory for the Great Division. So here were all the pictures I just showed you about the leading and lagging strands. Now, when I have made this brilliant copy of DNA, it is compressed into something called a chromatid. This chromatid, sometimes we will call it a chromosome. You've probably seen a shape like this. In fact, I think I drew one out. I drew one out. Well, I don't know why I kept it. But I drew one out the other day. And this is 2 copies of this DNA. Now, through the dividing phase, what I'm going to need to do is break this apart. Because right now, this chromosome made of 2 chromatids is 2 complete DNA. So what I'm going to need to do during the dividing phase is pull apart these 2 chromatids so that each cell has its own copy. So this is compressed DNA twice. This is a copied DNA. Does that make sense to everybody? Is everybody okay? Bueno?
So just for me, 'cause I'm a little slow, those chromatids, those little X's, if you cut it in half, that's going to be a replica, a mirror replica of the same of the other side, correct?
Yep. So here, when I am dividing this single strand of DNA, and I am now reassembling 2 strands, it is these 2 strands that are compressed. So here's a strand, here's a strand. Actually, it goes, yeah, and we break it here at the centromere, which is just at the center. So then we would have 1 strand of DNA for one cell and 1 strand of DNA for the other cell.
Okay.
All right, so we've gone through interphase. Our cell has lived a happy life. We've gone through the preparatory phase. We've gone through G1. The cell has gotten bigger. We've gone through synthesis. Our DNA has replicated. We go through G2. This is where we're packing a lunch. We're getting ready to actively replicate. The true mitotic phase is when we are actively replicating. So we have 4 phases to the mitotic phase. And these 4 phases are just representing how are we doing at separating into 2 cells. We're all ready to do it. We got our DNA packed and compressed. Everything's ready. The cell is twice as big. Now we're going to actively divide. So the first phase that happens is we are going to start to have what's called this spindle fiber. All right, if you remember from the last chapter, one of the components of our cells was this stuff called a centromere. Not a centromere, a centriole. Sorry, Doug's not on the wheel. A centriole. And these centrioles in the cell have now start to form these little fibers. And it is these fibers that are going to be used in one of the later stages. So basically, here we have our nucleus. Here I have all of my replicated DNA. DNA. The cell has gotten twice as large. And here we have my centrioles. Those were the ones that looked like little pieces of licorice. on the cell anatomy. Those centrioles have now started to form these fibers. And this is actually really neat. I love some of these pictures that I have found for you because this is the artist, obviously, rendition of prophase. This is an actual cell entering prophase. So it's pretty cool. So we have the spindle fibers that are going to be used at a later phase in this. Oh, you need to move here. And we have our picture right here of what is happening in a physical cell. Now, the last thing that's happening during prophase is all of our DNA is locked in the nucleus right now. We've got it all copied. It's all ready to go, but it's all locked away. And so what we need to start doing is having that nuclear membrane, the kind of the skin of the nucleus, start to fade away and break down. We need to free the chromosomes, free the DNA. Now, this is pretty cool. This is where we start getting a little excited. I have now completely dissolved my nuclear envelope. I have set the DNA free. Hallelujah. Here I have those centrioles, and you can see these spindle fibers. See these spindle fibers here? During metaphase, meta, all of these copied DNA chromosomes are going to line up where? In the middle. So these little spindle fibers have now attached one to each half of this copied DNA. Do you see how now I can start doing tug of war, pull them apart? That's exactly what we're about to do. So this metaphase is just where we have lined up our chromosomes, we have attached the spindle fibers. Look at this gorgeous picture right here. This cell is what in metaphase? Look closely. You can actually see the spindle fibers. These are the chromosomes lined up in the middle, and you can see the spindle fibers attaching to them right here. I'm outlining this. That is what we're talking about. See, I can't wait to get back because I want my appropriate amount of astonishment. And I am not getting that through the video. I am not getting my, I can only see 2 of you right now. Going forward, you know what? I think we're going to change that. I think I'm going to start making everybody do video because I need to make sure that you're not just gone back to sleep. Not saying that you did, but I got to prove that we're doing these contact hours. So I might go ahead and just make sure that everybody's doing video. I'm not going to make you do it today, but just know you may be getting an email from me later on. Ooh, I got a little spiky right there. All right, so prophase. Well, too bad, so sad. It's not a fashion show. Hi, it's not a fashion show. Yes, Casey, I can see you. Yes, be prepared. Be afraid, Jade. Be very afraid. All right, so prophase, we have dissolved our nuclear envelope. We have got our spindle fibers being created from our centrioles. Metaphase, nuclear envelope has disintegrated. Release the DNA. Spindle fibers have attached to them, lining them up in the middle. Here during anaphase is tug of war time. This is where our centrioles are going to start to move away from each other, and that's going to pull each half, one copy of the DNA, one towards one side and one towards the other side. We're going to start, go ahead.
Sorry, but your picture is covering some words. Can you tell us what they are? I just want to make sure that I notate them down.
Oh, I see what you're saying. Here.
Thank you.
Absolutely. Let me, oh, no, that's not what I want. Exit. Sorry, I had to go into my edit so that I can move it. Here's what I can do. Bear with me just a second, guys.
Sounds good.
All right. I got you. All right. So here's what I've done. I've actually taken the picture and just put it on a different slide. So during anaphase, what is happening is the lined up chromosomes are now being pulled apart. Those spindle fibers, those tug of war ropes are now pulling apart that DNA. One copy going towards one side, one copy going towards the other side. In the middle, we start to get a little what we call a cleft. Kind of like a cleft chin, like a butt chin. This is a Tom Brady chin. Here is a picture of all of that happening. I just put it on a different slide. So here is my spindle fibers. Here it's pulling this copy towards this side and this copy towards this side. And here we start seeing the cleft. Here we have, damn it, my chat is not working. You know what, technology is just not gonna work for me today. I don't understand it. Okay, worth it. All right. I have too much going on this tiny little laptop. And sorry, guys. My goodness. I don't know, my chat's not working, so you're just gonna have to unmute yourselves if you have a question. All right, so we have here this little cleft, and that's where our cells are gonna get ready to divide and become two. This is a fabulous picture. I love these pictures. You know what, I'm tempted to just have them printed out and like framed. I think they're fabulous. Here I have a cell going through the same phase, and you can see it. Look, dark, dark. That's the DNA being separated. This is going to become one cell, and this is going to become one cell. This is exciting stuff, guys. This is life. This is happening in you at all times. If this didn't happen, you cease to exist. All right, so the very final stage of mitosis. The final stage is cell division. So basically, the cleft gets deeper and deeper. We form a bilayer, right? We form a cell membrane in between the two, and we reform our nucleus. So now our perfect copy of DNA is housed safely in the nucleus. We have reformed our cell wall, and we have two brand new, well, technically one's not, but two perfectly copied cells. Bam. One cell, two cells. And when this is all finished, these cells will immediately enter interphase. Now remember, interphase, we also called it the metabolic phase, is where they're just going about doing their jobs, doing their little cell lives. And this just continues to happen over and over and over and over. So this is, now this has a couple of extra little phases, but that's okay. We'll just go over the ones that we talked about. So pre-division, let's just go back, do a wee bit of review. Interphase. Interphase is where the cell is not dividing. The cell is not even thinking about dividing at this point. He's just doing his cell job. Then we have the growth phase, the synthetic or synthesis phase, and growth 2 phase. Growth 1, the cell gets double its size, because if I'm going to make 2, I need the size of 2. So the cell doubles in size. During the synthetic phase, I copy my DNA. That's where the leading and lagging strand comes in. I'm going to copy, copy, copy. During my growth 2 phase, that's where I'm just making sure that I have a lunch packed, I have enough nutrients, I have enough protein to make this whole thing happen. During my active, gonna now separate into 2. We talked about the prophase. Prophase is where the cell has now made a decision, I'm gonna divide. I get rid of the nuclear envelope because what do we need to do? Release the DNA. I am going to start having my centrioles. Centrioles were the little things that look like little pieces of licorice. Those centrioles are going to start creating the spindle fibers. Metaphase. This is where we line up the chromosomes and the spindle fibers, you can see here, attached to them. During anaphase, we have this tug of war. This is beautiful. Look at that. Oh, I'm way more enthralled in my own pictures than you are. This is half one perfect copy. This is a perfect copy. And then during telophase, we rebuild the nucleus and we rebuild the cell membrane. We now have 2 identical copied cells. Ta-da! It feels like a magic trick. It feels like I need to say ta-da. This is amazing. You guys, wow, yeah. That's the other problem is I can't make you do yoga or anything. Like usually, yeah.
One question. What happens, because you said they all come, they all split perfectly and it's a mirror image, but what happens like when you have like those animals or humans that have Down syndrome? Like where does that take place? So what you are referring to are genetic mutations. Okay. That is happening during meiosis. When gotcha. I have a number of genes or genetics that are supposed to come from dad's sperm and mom's egg, and they bippity boppity boo, new baby. But the difference is with the genetic mutations, that could be where part of the DNA strand is incomplete, or we get too much of it. In fact, with Down syndrome, it's because they have an extra
chromosome. They have an extra gene. But the difference between that and what we're talking about is that is not meant to have an exact copy. It is meant to take half. So in mitosis, we made an exact copy and donated half to each cell. In meiosis, so instead of dividing, I'm combining. In meiosis, I have half of a copy and half of a copy. These will make one whole strand of DNA, but they have to combine it to do so. So we're not really dividing, we're combining. And so that's where you're going to get your genetic mutations. Like I had a mutant. My beloved Bentley was a mutant. He had 5 legs. And that was because he had 5. I told you all that. My 5-legged dog. Yeah. He, at some point, either in dad's genes or mom's genes, when we were looking at the DNA, something was wrong. Some pattern, something was out of whack, and it gave him his 5th little leg. So that's just a problem with the reassembly. That is not what is happening here. So with mitosis,
mitosis, we're just splitting and dividing the cell.
yes.
Meiosis is when we're getting one part of one and part of another and combining it.
Yes.
Okay.
And so the biggest difference is the result. With meiosis, like reproduction, the cell that has now been created is completely individual and different from the cells that created it. In mitosis, what we're talking about here, the cell that has been created is an exact copy replication of the other cell. Now,
Okay.
Can you have problems with mitosis? Yes. Is that considered like, am I going to suddenly start sprouting a leg out of my neck because of mitosis? No, but you can have issues with mitosis. You can have cells that over-replicate. And that's going to cause, now it's also caused by genetic issues, but over-replication, let's say you over-replicate your epithelial cells. Suddenly now your skin's going to get super, super thick because you are over creating those cells. And so can things happen? Absolutely. But it's a different result than with the reproductive. All right, I have, let me see here. And I have a really cool, hopefully my internet will hold up long enough, because I have an animation that is really pretty great. And I think, is this it? Yes. All right. So let me just show you, because sometimes seeing it in motion is a little bit easier. So move you guys over here. Move it. Do this. And share my sound with you. All right, so what this is just like a little minute-long animation of everything that we just talked about. So here you go.
Mitosis begins as the long threads of DNA in the nucleus start to coil. Having already replicated, these threads emerge as the double strands we know as chromosomes. Meanwhile, protein fibers grow from the migrating centrioles, forming a latticework of spindles. For reasons scientists don't fully understand, the nuclear membrane suddenly disintegrates. With amazing accuracy, a spindle from each centriole attaches itself to each of the chromosomes. Assisted by the protein fibers, the chromosomes move center stage. In a microscopic tug of war, the spindles pull each chromatid toward opposite poles. Other spindles push against each other in a ratcheting action that stretches the cell. The chromosomes then unwind and the nuclear membranes reform. With mitosis complete, the nuclei and cytoplasm separate, creating two new cells in this ongoing cycle that sustains all life.
Excuse me. All right, so watching that video, were you guys able to pick out the individual stages of mitosis that we talked about? Okay,
Yes.
good. Very good. All right, so now that we know how our cells are dividing and creating a perfect copy, how do they know when to stop? I mean, because eventually we have enough cells and we don't want to make any more. We don't want to overproduce. Well, here's what's pretty cool is we have what's called contact inhibition. So here's what that means. If I am a cell and I am replicating, let's say I'm a liver cell, I'm a spleen cell, I'm a kidney cell, and I'm going to make a copy of myself and make a copy of myself. And the organ space, let's just say the organ is my kitchen. And I need to make just enough copies of myself to fill up this space. But once I have filled it up, I need a signal to say stop making copies. And so basically what contact inhibition is when I've made enough copies that I am now standing shoulder to shoulder, front to back with my cells, that's my signal, don't make any more. So once I come in contact with these other perfect copies of me, I am given the order, don't make any more copies. Now, if some of these cells die off or some of them for whatever reason go away, do you see now I'm gonna have these cells move away from me. If I don't have a detection that the cells are shoulder to shoulder, back to front, then I'm gonna start making more. And so as long as they're in contact with other cells, they will have this inhibition. They will not recreate, they will not go into mitosis. They will stay in that metabolic phase as long as they need to. They can stay in that metabolic phase and just do their little cell lives and do their little cell jobs just for as long as they need to. It's not a predetermined set amount of time. It's when I no longer feel the cells around me that will send me in to start preparing to divide and create more of myself. Does that make sense to everybody?
Yes.
Good. All right, so this is how do we create proteins? So we have now divided our cell. We have two healthy copies. Now we're just going to talk a little bit about some of the things that the cell does. So if you remember from last chapter, when we went over the anatomy of the cell, I'm going to keep using these words because you need to keep hearing them. We have the blueprint for everything that the cell is doing. That's our DNA. I can take a section of that DNA, which is a recipe for, name your protein. That section of DNA that I have now copied, okay, I'm just like, it's like I'm at my mom's house and I'm copying down one of her recipes. Take that recipe, I get all the groceries I need, bippity boppity boop, I make the thing. That's exactly what's happening here. So I have my DNA, my cell or my body is saying, hey, we need XYZ protein. And so I go and I write down the recipe for XYZ protein. And I'm going to ship that out of the nucleus. And I'm going to pick up all of the ingredients. And I'm going to manufacture and make XYZ protein. That's all I'm saying here, except with fancier words. Transcription. To transcribe means to what? Make a copy. Make a copy. Transcription is where my RNA is just making a copy of the recipe for the protein that I need to make. The messenger RNA is what is going to transport that RNA out of the nucleus. There's nothing I can do in the nucleus. There's nothing there. There's no ribosomes. There are no factories inside the nucleus. The only thing the nucleus is good for is providing a silver palace for our DNA. Wow, apparently I'm a little bitter about all of that. That's all it's good for. That's it. I got to get it out. I got to get it to the workers, the essentials. We all know that word right now. The essentials. Translation is just that. I need to read it and follow the directions. So translation is where I'm going to bind with my ribosomes. Ribosomes are going to read the ticker tape and they are going to build the new protein. So that's all we're talking about. These are sciencey words for copy the recipe, get the ingredients, cook the thing. That's it. Transcription, get the recipe. Messenger RNA, go into the grocery to get the ingredients. Translation, I make the thing. That's it. Any questions about any of that?
No, I think I'm good.
So, just to clarify for myself, the tRNA is the one that's like writing down the recipe, and then the mRNA is what's making it?
So the mRNA, M stands for messenger.
Okay.
So if you think your messenger is the one that's making the trip to the grocery. So once I have the tRNA, that would be I have transcribed, I have the copy. Messenger RNA is going to take that copy out of the nucleus and find a ribosome. The translation part, or rRNA, the R in this case stands for ribosome. And this is where the ribosome comes down, reads the little ticker tape, and makes the thing. So translation RNA, tRNA, we make a copy. mRNA, messenger, I have that copy leave the nucleus. rRNA is where a ribosome now joins our copy and makes the thing.
All right. Thank you.
No worries. Look at that, Bernadette.
Yay.
So, genetic mutations, as we just discussed, genetic mutations are generally going to occur during meiosis, where there's something has gone terribly wrong with the mishmashing of these two different genetic codes. But we can get cellular mutations based on an incomplete or incorrect copying of the DNA during mitosis. Now, this is not, although we say genetic, meaning it's messing with the DNA, it's not genetic like what you're thinking of, like when the baby comes out turned inside out. That's during the reproductive cellular creation. If I have, some sort of cell that is damaged, and now that cell through mitosis, perfect copy replication. Well, perfect copy replication means just that. It's going to make a perfect copy. Now, that doesn't mean it's a correct copy. It means it's an identical copy to the thing that it's copying. But what should happen if the thing that I'm copying is broken to begin with? And we're not going to make a broken copy, and then that one's going to make a broken copy, etc., etc. Yes, that's exactly what's going to happen. All right, let's talk about this in what is happening right now in the world with and then bam, cancer. Yes, Jennifer. Yes, you guys called it. Bam, cancer. That's exactly what happens. But let's talk about this, about what's happening right now. So we have this virus, this COVID-19, this gosh darn thing bug. Now, here's what's making this virus pretty dangerous. So we already know from our other lectures that one of the things that's super dangerous about this virus is none of us have ever seen it before. None of us have ever been exposed to it before, which means every single one of us is going to get it. It has nearly a 100% chance of morbidity. Morbidity is the word we use. There's some of your midterm. There's your midterm. Morbidity is the percentage of a population that gets infected with a disease. Mortality is the percentage of those infected that die. So when you hear that something has a very high mortality rate, it means a large number of people who get that disease die from that disease. If it has a high morbidity rate, it means that a very high percentage of people who come in contact with the disease get the disease. So, what does that have to do with our friend COVID? 100% of us are going to get it. The eliminations were too late. The testing is not being done. I'm not even going to get on my soapbox about how woefully unprepared the American government was for something like this. They don't even have a pandemic team anymore. It was disassembled 2 years ago. What does that have to do with genetic mutations? All right, so certain viruses can go in and kind of have some fun messing up the DNA code. And they get themselves, they'll go into the cell. They will just kind of like, let's just put this over here, we'll put this over here, and we'll put this over here. And they mess it up. Now, they're not messing it up to the point where, bam, cancer. But what they are messing up is because remember the DNA is the blueprint. That's what the cell is using to do its job. Without that blueprint, I don't do an appropriate job. Once he messes up the blueprint, now when those cells are replicating through mitosis, they are replicating the messed up copy. The virus has gone in and rearranged stuff. And the cell is now replicating that rearranged DNA. And you see now that cell is going to have rearranged DNA. And that cell, until eventually every cell we have has rearranged DNA. Why does that matter to us? This virus attacks your lung cells. So what they are worried about, and what we don't even know, because we don't know what long-term issues are associated with this disease, but they're now saying that long-term lung tissue damage is very, very possible because of the way that the virus has gone in and rearranged. And now this little lung cell is looking at this blueprint going, I don't know what I'm supposed to do in here. And then doesn't do it. Well, you can't live without your lungs. And so if that's the case, we are in very, very big trouble. Because if you have nearly 100% morbidity and 100% of those people get the disease, even if you only have 30% with long-term lung problems, you're looking at a healthcare system that is already broken, now being overwhelmed with respiratory patients. Bam, not cancer. Right? So, some other things that can go in and scramble up some of this DNA. Radiation. Holy smokes, radiation will mess up your DNA so that not only is your mitosis messed up, you're going to be replicating incorrect cells, but your genetics, your reproductive cells are going to be all scrambled up. So when you are combining your cells to make a baby, or when you're splitting your cells to make other cells, the whole thing is messed up. Just watch Chernobyl. It's insanity. Chemicals, certain drugs. In fact, the entire premise of chemotherapy is that it is selective. It's gonna go in and it's gonna hopefully target only the cells that have the mismatched DNA. And it's gonna kill off those cells, only leaving the good, healthy cells to replicate. And if we can get those good, healthy cells to replicate, then we will repopulate the area with good, healthy, normal DNA cells. That's the whole point behind chemotherapy. So holy smokes, boy, I got excited there, didn't I? I did get excited, and that's time. We're gonna pick it up here and finish this up tomorrow, if I can stop this. Let's see. How much more do we have? Oh, we're almost finished with this one. Now, I've already given you a test this week, so I'm not going to give you another test this week. We are going to do a review on tomorrow. We'll have a test probably. I know you guys have a big intro test on Monday, right?
Yes.
Okay.
Yeah, we do.
So even though it will kind of put it, the test will be behind a little bit. You know what? Actually, you guys, this is a democracy. Here is your option. We can start the next chapter, but delay doing this chapter test until Tuesday. Or we can start the next chapter and I give you the whole weekend to do this chapter test. Would you prefer the test to be delayed, or would you prefer the test to be over the weekend? Up to you. Don't tell me now. You guys get together and you guys figure it out, and you guys tell me what you want to do tomorrow.
But we will review it tomorrow as a class.
Oh, yes.
Once we finish it, we'll review it. Okay.
Yep. And I may be able to schedule some sort of tutoring session either tomorrow or, tomorrow after class, or maybe sometime on the weekend. I'm not sure about the weekend, but I might be able to schedule something. If you guys are available, I may even be able to schedule something. I have a meeting at 3, but we could always do another tutoring session at 4 or 4:30. So if you would be interested in showing up for a tutor, not even just for A&P. I know you guys got a big intro test. I can help you with that. Guess who knows all of her abbreviations? This girl right here. So I'm going to go ahead. Here's what I'll do. I'm going to go ahead and form a room at 4:15. I'm going to send the invite to everybody. if you're interested in coming in for some fun, and we actually have a good time. Those of you that were in the last one, it was a lot of fun. We'll just go ahead and do a study session at 4:15. So,
4:15 today?
yeah, 4:15 today.
Okay, great.
All right, guys, I'll send you that invite and I will see you tomorrow.
Bye.
What?
Hi, I was just trying to make sure when that test yourself questions, how we were doing that.
I'm gonna look into the Edmodo.
Okay.
So if
hold on to it.
Just hold on to it. If you guys are, the majority of you are having trouble with the Dropbox, hang on to your questions. I'm gonna go in and I'm gonna look at the Edmodo right now. Actually, no, I'm not. I'm going into class right now. I will look at the Edmodo as soon as I'm finished class, and I'll send you all an email and let you know if I've uploaded an assignment that you can attach it to.
Okay, thank you.
You're welcome.